in this section, there are going to be some questions about discrete versus continuous. Well, guess what? We already talked about discrete versus continuous yesterday. So let's just real quick, I want somebody to raise their hand and describe to me the difference between discrete and continuous. Abby?
Discrete means it comes to a point, stop at some point. Continuous means it just goes on for infinity.
Okay, I agree with some of that because this guy right here is continuous. This does not go on forever. So let's just kind of tweak your words a little bit.
It just keeps going. It keeps going, but eventually will stop.
There's no point where it stops.
But that there is.
How
Why
many,
not in the middle of it?
how many numbers are in my domain?
130.
Isn't there an infinite number of points right here?
Yeah, sure.
Yes, there's an infinite number of points in my domain and range. In discrete, are there an infinite number of points?
No.
No, there's a set amount, okay? So if I'm looking at so 13 and 14 are discrete, they're just dots. 15 and 16, those are continuous, okay? We have like a line or a curve where we have a lot of dots all put together, okay? Are you okay? Yes, you did. Okay, so our main focus today is going to be the difference between a linear and a nonlinear function. Okay, so when I say linear,
1,000 means like
line, and I'm talking about a linear equation, it is representing a line. Okay. Okay. So we are going to have an equation that looks like this, or can be rewritten to look like this. Y equals mx plus b is something that we're going to talk about next week after we take a quiz. Okay. But what you notice is that both x and y have exponents of 1. Okay. Like this is x to the first, but I'm not writing x to the first. This is
also b to the first.
Technically, yes, but b is going to be a number, m is going to be a number. So for example, y equals 2x plus 3 is a linear function. Okay. I also could say 2x plus 3y equals 5 is a linear function because I could solve for y like we did with our literal equations. Remember that? I could solve for y to get it to look like that. Okay. So really, as long as x and y have exponents of 1 and they're not being multiplied to each other, then we're good, or divided. Okay. They would need to be added or on the other side of the equal sign. Okay. So now let's talk about the some special properties of a linear function. Okay. So a linear function represents a line, and I do need to specify that it is a non-vertical line. Why am I saying a non-vertical line? I'm going to draw a vertical line.
it's horizontal.
It's vertical.
I know, but
If this is a function,
it's a non-vertical line, which means it's horizontal.
I know, I'm drawing a vertical line. What's true about this line? It's vertical.
It's not horizontal.
Does it pass the vertical line test? No, so it's not a function. Okay, so any line that is not vertical is a linear function? Okay. Something very special about a linear function is that it has a constant rate of change. That's something we're going to talk about specifically calculating next week. Okay, but whether that rate of change is positive or that rate of change is negative or the rate of change is 0, those are all lines right there.
Yeah. What do they pass for what?
Do they? You tell me. Separately? Yeah, they do. Okay. Things that you pick out. Okay. Now, a nonlinear function is not a line. I know. It's well, it's a function. The squares would not be functions. Okay, so it could be something that looks like this. That is not a line. Okay, it could be something that looks like this. That is not a linear equation because x has an exponent of 2. A line is straight. Okay, so we call that a curve. Okay. Okay, so we need to be able to look at a piece of information and determine whether it is linear or not. Okay, so I'm gonna have you, well, first, actually, I'm gonna go have you come down to this notes section. And I want you to understand that we could have a vertical line. It would not be a function. Okay, and when that happens, we would have x equals some number, like x equals 3, or x equals 4, or x equals 72. Okay, it would not be a function, but we can graph a vertical line. Okay, we could also graph a horizontal line. My goodness. Now, a horizontal line is a function. But what's weird about a horizontal line is that all the y values are the same. So its equation isn't going to have an x. It's just going to be y equals b, some number b, like y equals 5 or y equals 17. Okay. So I want you to understand that if I'm asking you to determine like, oh, if this is a linear function or not, if it's just y equals a number, if there's no x, it's okay. It's just a horizontal line. And we'll go over that again numerous times throughout this chapter and the next. Okay. All right, Colin,
What? Yeah,
we're up here.
okay.
Okay. All right. So I want you to head over to this page right here. Okay. So all of these represent the same linear function. Okay. So I want you to look at this y equals x plus 3. Okay. So notice how this looks like that y equals mx plus b format, okay? M and b are gonna be numbers. So this 3 is like where the b is. The coefficient of x is what? Is 1, okay? So we know that this is a linear function, okay? Another way that I like to tell is by looking at my variables, okay? X has an exponent of 1. Y has an exponent of 1 and they're separated. Okay, as in they're not like multiplied or divided. That would not be okay. Okay. Now, if you have an input-output table, I really want to talk about what it means to have this constant rate of change. Okay, so there is a function on your family's vehicle. It's called cruise control. What is cruise control? Who can tell me? Amelia.
It's like when you like says and then it just like goes up
Okay, so it just like keeps your car going the same speed, a constant rate. All right. So if you're going 60 miles per hour with the cruise control on, then what does that mean? Every hour you go 60 miles.
You
Every
know, 1 mile
hour-
per minute.
You're
Okay,
going light speed.
every minute
You
you've got a mile, all right? So, and it doesn't change, right? It's not like, oh, in this minute I've gone 2 miles. Nope. Every minute you go a mile. So in order to figure out if we have a constant rate of change, our x's need to be changing at the same amount. So let's test that. From -1 to 0, that is up 1. Okay. From 0 to 1 is up 1. And from 1 to 2 is up 1. Hold on. Okay. Now, our y's need to also be changing consistently, but they don't have to be the same as the x's. They just need to be changing at a rate that is constant. It turns out we have the same rate, but from 2 to 3, we go up 1. From 3 to 4, we go up 1. And from 4 to 5, we go up 1. So yes, this is a linear function. More copies. Thank you very much. Nope. So I want you to come down here. We're going to make an XY table. Okay, please copy down this XY table that I have written up here. So let's look at our x's. From 2 to 4 would be up 2. From 4 to 6 would be up 2. Okay, so is that constant? Okay, we have the same rate for the x's. Okay, now the y's from 0 to 3, -3, excuse me, is down 3. From -3 to -6 is down 3. Now my x change and my y change don't have to be the same, but my x change needs to be constant and my y change needs to be constant. So since my x's are changing at the same rate, we're good there. My y's, are they constant? They change the same. So yes, this is a linear function. Now, if we look at the graph is going to be a line with slope. I know, it's amazing, right? So this is it, okay? All right, so let's go ahead and let's turn the page, and I want to look at these two graphs right here. Just 1 and 2, you and your elbow partner decide. Is 1 linear or non-linear? Is 2 linear or non-linear? Yes, I do.
Where is she?
She's not in this room.
Wait, she transferred?
No, she'll be in class tomorrow. Okay, Nirvan, is number 1 is a linear function? Why not? Okay, it's not a line. Okay, number 2, Avery, linear or no?
Linear.
Okay, no. Okay, and how do we know? It's a line. Not the best. It's a line. Okay. So now let's look at our tables. Okay. So now I want you and your elbow partner, we've done a couple tables together. I want you to look at 3 and 4 and determine whether those are linear or not.
There is a difference between numerator and denominator.
Right.
I had to get that.
Okay, figure out if those are linear or not, okay? Have you figured it out?
Yeah. Oh, those.
3 and 4. 3 and 4.
Wait, Miss Hogan, for Y's, does it have to change by?
So the X's need to change by the same number. The Y's need to change by the same number.
No.
But the X's and Y's can change. Like, so in the example that we did over here, like these weren't the same number, but like from X to X, they're the same, and from Y to Y, they're the same. Did that get across? Okay. Okay, Preston, is number 3 linear or non-linear? Okay, Preston says that number 3 is linear. Do you agree? Okay, it looks like the X's have a constant change of +1, and the Y's have a constant change of +3. So this is a linear function. We have a constant rate of change. That would be your explanation. Number 4. Gus, is this linear or non-linear? Just no?
Yeah.
So linear or non-linear? Thank you. Okay. So our X's have a constant change of 1. That's good. But our Y's, we go down 1, up 3. Ooh, well, that's not cool. Okay. So that's non-linear. Okay. All right.
Oh, no. Number 6.
Oh,
Okay. Number 5. Raise your hand if you think this is a linear equation, a linear function. Raise your hand. Everybody should be raising their hand. Number 5 is a linear function. Colin, why is it linear?
Because there's no exponents.
Okay. There's no exponents. We can write it as y equals mx plus b if we just rearrange these around. Okay. X and y have exponents of 1. Okay. Now, if you scan your eyes over to number 6, no. Okay. X has an exponent of 3. That's not okay for a linear function. Okay, so this is what we're going to do. We have about 10 minutes where, guess what? I'm going to let you start your homework.
No.
yay.
Oh my God.
Okay, so here's the deal. You need to give me about 2 minutes and I'll have this uploaded into Google Classroom. But for right now, I'm gonna have you look at it off of the board. So who has their gold sheet out?
5 through 14.
5 through 14?
I don't know. I might be wrong.
Wow.
I took an educated guess.
No. Extra gold sheets are up here if you need one. It looks like it's 5 through 30.
Oh, 30.
You get to write linear or nonlinear.
Oh, that's why.
Linear or nonlinear.
Oh, that's, oh, I thought for some
Okay, so
reason you
do
meant
math.
multiplication.
Wait, is this 3.2?
Never mind.
This is 3.2. Okay, so give me like 2 minutes. Oh, sorry, that's the wrong button. Give me 2 minutes and it'll be in Google Classroom for you.
Yeah, okay, like screen. Well, that's good. You got those answers too, right?